In that last job, we submitted 3 run numbers against a genome to look at the SNPs. And in the last video, we looked at all the files that come as part of that job. We went to jobs and I opened up this particular job and there were a bunch of files and we stepped through all of them. And I would encourage you to look at the tutorials in case you have any questions about those. In this particular video, I wanted to focus on the TSV file for the variants. Now, for each of those, we had it for PE1, PE2, PE3. Each of those have that particular file format. This one downloads them all together. So remember what it looked like. This is the HTML of that, and I think it's pretty awesome rendering where you can see all the information, but it's a lot of scrolling. You can't really filter on it in this format. We also provided you with the table where you could scroll down and look at things on it. So I can view that, and we could do this and filter for these things, but still I'm more comfortable with Excel. So I want to show you how I download that and look at those things in particular. So from here, I'm going to click on this and I'm going to click on the download icon in the green action bar. And remember, this is a tab separated value. So if I were to go in and just click on it, this is what it's going to give me, text value. Ugh, I don't like it like this. So I opened the thing in Excel. So here's the Excel rendering. And so let's step through this. This is showing you the sample, what config it's on, and I can open that up. This was in a number of contigs, this genome. So each of them have their own separate SNPs. This is the position on this config. In this place, our reference genome had a T, our variant genome had a G. There was a particular score. This is the coverage, how many variants were in that position, and what percentage of them had that particular SNP. So even though this was only 22, 100% of them had it. It was non-synonymous, meaning that the amino acid changed. It went from a GTG to a GGG. There was the change, the codon number where the change occurred, the amino acid change that resulted. This is the unique gene ID. Now, if this was a BV-BRC reference genome, it would probably have a RefSeq locus tag and also a gene name that came from RefSeq, but this is my private genome, so you don't see that. This is the particular function, and we can scroll out with this. It shows you upstream, downstream regions too. It tells you what type of SNP, what effect it was. So this was a missense, the amino acids changed, and it shows you that it's moderate mutation. Now, if you look through all of this, if I just click on this, and it's going to tell me that there were 220 total SNPs in this. But the ones I am interested in are right here in this particular gene. This gene is dihydrofolate reductase. It's important in folate synthesis, and trimethoprim, the antibiotic, acts on this gene. So it's important in resistance or susceptibility to trimethoprim, which is what we're going to look at. In a later video, we're going to look at a structure and see exactly where these mutations are occurring. So I want to capture all this information, and I always like to color things so I can see it clearly. And you can see that all 3 of the samples are sharing the same mutations at this position and this position. And that this one, 2 of the samples have that same mutation, and some of them have unique mutations in that. Now, most of them result in an amino acid change, except for this one. This one is low, which means it's a synonymous change, a valine to a valine, and I'm never very interested in that. But let's pay attention to this. So it's the sixth contig. The first part of this number is the unique genome identifier. And then it says .con, which is for contig, and then 006. So that's 6. And it's going from the 169,672 to 17216. I just want those locations because that's what I'm going to show you guys on the genome browser in the next video. So all the information is here, and you can see which ones are shared across multiple samples and which they have alone. And also, I always pay very close attention to how deep the coverage is at these locations. Now, some of these you're going to have to look at them on an individual basis when it's combining several of them together to show the depth of it. But this is giving you a good indication. And if you look through all of these things, like I could go up here, I'll just show you some of my handy dandy Microsoft Excel techniques. If I go up here and I do freeze panes, and if I wanted to do this on coverage and then go into data and sort based on the coverage, and I want to do it on everything. And so I'd go variant coverage, and I would always want to go largest to smallest. So you can see that where this is a good way to give you a sense as you scroll through it, and it's still keeping those guys highlighted that we had, of who has more data. Some of these have a lot more reads there, like this one's terrible. 2.5 because it's going across 2 different samples. So probably one is, I'm not sure of how the numbers are calculated, but it gives you a sense of where they are in those values. So it's ranging from 154 to 2.5. Okay. In the next video, now we're going to look at these on the genome browser, which is an awesome functionality, and I will see you there.